Okay, hi. Today what we're going to do is take a look at climate and landforms. What you have already is a note sheet and a packet. And what we want to make sure that you understand as you're watching the screencast is, one, what's the difference between climate and weather? And then two, what are the various things that do affect climate and weather? And give some examples, understand how it plays together. What I'm going to do is walk through these very things and try to explain it the best I can. And if you have any questions, please make sure you write things down so you can ask in class. As you're listening and watching what I'm presenting to you, please make sure you're taking some good notes that are going to make sense to you as you study and review. Keeping in mind our essential question is, really, what's the relationship between people and their environment, and what makes the environment what it is? So, that being said, climate and weather, there's actually two different ways that they mean, and what we want to do is understand the difference between the two. Weather itself is a short-term phenomenon. So as I'm sitting here recording the screencast for you, it's a rainy day. It's kind of cold, it's drizzly, and it's wet. Very unusual for San Diego because usually it's sunny or warm or at least balmy. So today's weather is going to be a short-term phenomenon, and today it's a rainy day. Now in the bigger picture, looking at San Diego, the climate, that's kind of atypical or it's unusual. So if I was to talk about San Diego's climate, in general, I'm going to say it's sunny, it's dry, it's warm. But day to day, the weather can change. I'll give you some examples of that. Could be just here, just talking about Johnny. Johnny was at a party the other day, and he was a real jerk, which is strange because he's pretty mellow. So if we want some examples, the idea here would be that Johnny's climate, if you will, his long term, is that he's a pretty mellow guy. His weather, or his short term, is that he was just kind of jerky, and we don't know what's up with that. Maybe he's just having a bad day. Finally, I have an example here too about San Diego. It's typically the weather would be rainy in January, but the climate is going to be a pretty dry place to go. So if you can understand that weather is short term and climate is long term, you got what you need here. Okay, a mnemonic or a way to remember things. When we're talking about climate, the mnemonic to remember the factors of climate is "oh well." And if you can remember "oh well," it's going to help you out. And as you notice on your note sheet, "oh well" will stand for O is ocean currents, W is wind currents, E is elevation, and the L's will stand for latitude and longitude, or latitude rather, and landforms. Sorry about that. Does it matter which order the L's are in? No, we don't care. But we do want to make sure that you're understanding what things mean and how it fits in with climate. So, oh well. O, ocean currents. Well, as you know, Earth is mostly water. We got water everywhere around us, and this ocean is going to really do an awful lot to impact the climate and weather that's going to be near it. So if you look at these currents, you're going to notice that some of them are red, which means that they're warm water, and some of these things are cold, which means that they're blue water. And what's happening is these waters are automatically circulating themselves around. The cold is kind of mixing to the warm, and then it kind of mixes back to the cold. And you're going to notice that the warmest water is going to be right here on the equator, where we get an awful lot of sun. So obviously the water is going to be warmer, and things mix. So the example would be kind of like the bathtub. You turn on the bathtub, and the water's always cold. And you get that running for a minute or so, and then it starts turning to hot water. But you start getting these weird patches of cold water and hot water inside your tub. And so what you tend to do is you tend to stir things together, and you try to make it all the same temperature. Our oceans do the exact same thing. The hot equatorial water is going to be mixing with the cold polar water, and it's going to try to balance out. Now, where the hot and cold meet, there's going to be some strong currents, and this is where we're going to start getting like weather that actually forms, like storms and things like this. So just keep in mind that if you're by a warm water place, it's probably going to be always pretty warm, and then if you're by a cold water place, it's going to be kind of cool. So look at, say, at San Diego actually has a cool water current coming by it. So, when you think about it, year-round, San Diego, by the beaches, is typically like in the 60s year-round. If it gets colder than that inland, like in East County, it's going to be generally closer to ocean temperature by the beaches. And when it gets really, really crazy hot here in East County, it's going to be, again, about ocean temperature over by the beaches there. So that water is going to do an awful lot to affect the climate and the weather. And then, of course, this is where the storms are going to be churning up and coming on in. Wind currents are going to be the exact same as air currents. If you're living in a place that gets a lot of sun, you're getting a lot of sun along the equator. So it's just going to be warm. The water is going to be warm, and so will your air. And conversely, if you're down in the polar areas with really, really cold water, you're probably going to have really, really cold air. And so these winds are also going to be blowing circles, just like as you saw with the water currents. And this will also be delivering cool and warm airs to you. And places where you have the cold and warm air mixing is where you're going to start seeing some storms and some weather phenomena as everything's trying to work itself out. Elevation. Elevation is kind of like the wild card here because elevation can happen anywhere. Elevation is going to be talking really about mountains and how high up you are in relation to sea level. And typically, the higher up you get in elevation, the cooler you're going to be. What you see in this picture here is some giraffes standing in front of Mount Kilimanjaro, which is in Tanzania, Africa. When you tend to think of Africa, you don't think of snow-capped mountains, but they got them because that elevation is so high there. So the higher up you are in the mountains, the colder it's going to be. And if you live in a mountainous region, of course, it's going to be cooler than places that are non-mountainous. In average, you're going to be losing about 3.5 degrees on average for every 1,000 feet that you climb. So if you're 10,000 feet up, you're probably going to be on average about 35 degrees cooler. This can be on any continent, this can be any place, and this is regardless of latitude. This is important to keep in mind. Latitude. Well, as you know, Earth is tilted, and because Earth is tilted, the tropical regions between 23 north and south are going to be getting the most sun. Since they get the most sun, they're going to have the warmest water, they're going to have the warmest air. So the closest you are to the equator, the most consistently hot and sunny it's going to be for you. The poles, very, very uneven. Because the sun is so uneven there, it's going to be very, very cold. And then if you're between the tropical regions and the polar regions, you're going to have some varying extremes depending how far away you are from the equator itself. So when we look at the ideas of line of latitude, this will give us an idea of how consistent or inconsistent the sunlight's going to be. In general, how warm or how cool the water in the air is going to be, and that will affect your climate. Living here in San Diego, our seasons are not quite as extreme as if they were, say, up in Maine, which is going to be farther up northern latitude. And this is all going to be a function of Earth's tilt, which, as you remember, is going to be at 23.5 degrees, which is why the tropics are at 23.5 degrees. It's an offset from the tilt of the Earth. Okay, so if you're applying latitude to water and wind, let's take a look at this. Well, our hottest places are along the equator. What do we notice about the water? It's warm. What do we notice about the air? It's warm. If we go up to higher latitudes like 60 degrees north, what do you notice about the cold water? It's cold. Same with our air. Inconsistencies. And that's going to be a big, big thing impacting our climate. If we live by places that have warm water, we're typically going to be warmer. If we live by places that have cold water, it's typically going to be cooler. And if you live places that are farther away from the equator, you tend to have more extreme climate or weather. Landforms can also affect the precipitation you get, and that's known as the rain shadow effect. And so what you're going to be noticing here then is there's going to be two sides to a mountain. If you look at any kind of satellite picture, you're going to notice that one side is going to be really green, and the other side is going to be pretty dead looking. The reason for that is because the mountains will actually block the clouds, and what the clouds have to do is they have to rain off a lot of their weight in order to get up over the mountains. By the time that happens, they're really wispy and weak, and there's nothing left to rain. And so the inside part of the mountain is called the leeward side, or you also have what's known as the rain shadow, where it really just does not get very much precipitation at all. And if you've ever driven across the mountains going Interstate 8, getting past, getting into Borrego and that place, you notice that there's a very, very big difference depending on which side of the mountain that you live on. So bringing it on home, San Diego is a really cool place geographically because we have different climate zones. We have the microclimate. Not a lot of cities do. We're going to have our coastal climate, which is typically going to be the most, consistent, but also relatively cool because it's right by the ocean. As you know, being inland is typically going to be a lot warmer than the coastal area, and it gets pretty hot here in the summer, and much more so, than it is by the beaches. As you probably know, going up to Julian, it tends to be a little bit cooler because you have a higher elevation, and December, January, you tend to get snow up there. And the deserts are just crazy hot and crazy dry because they're on the leeward side of those mountains. And it's pretty extreme over there. So this is a quick overview of climate and weather. Remember, climate is long-term, weather is short-term. Oh well, ocean, wind, elevation, latitude, and landforms are going to impact your climate, and now you have a better understanding why. Thanks for watching and listening, and have a good day.